Bismillahirrahmanirrahim. I'm Zair Khaled today explaining my final year project, which is traffic signal violation detection using computer vision and IoT. I completed this project with my project mate Abdur Rahman Arif under the supervision of Dr. Junaid Ahmed Bhatti and Dr. Gulsher Ali Bloch. So if we talk about the introduction of this project, so first we will discuss the problem statement. In every city there is a lot of traffic. Due to this lot of traffic, there are so much problems about the traffic violations. Due to those traffic violations, we have traffic accidents which can cause serious injuries and casualties of people. So currently there is a human observation for detecting those traffic signal violations. We need to implement traffic wardens on crosswalks and other traffic signals to monitor currently those traffic signal violations. What we propose an automatic traffic signal violation detection system which can automatically detect the traffic signal violations and feedback those information to the respective authorities. So if we talk about motivation behind this project, so the first and the best motivation for second this project that we want to learn the computer vision and image processing tools because these are the most widely used tools and we want to complete our master studies in this domain. And we have also observed a gap in the implementation of advanced technological solution for the law enforcement authorities. So that's why we have selected this project. So if we talk about the aims and objectives of this project, so these are some technical objectives of this project. First of all, we have to design the miniature traffic environment where we can visualize the real-time traffic signal violations and detect those violations by using our system. Design of the automatic traffic signal lights in which we can visualize the switching of lights from red to green and green to yellow, etc. So after that, the red light violation detection system, which is composed of computer vision tools, which can actively detect traffic signal violations. Capturing a red light violation image of the traffic, when it will detect the traffic signal violation, it will capture those images and save it to the local PC. And after that, it will also count the total violations per day and feedback those information to the authorities. And also, we are going to implement the license plate recognition for this project, which will detect and recognize the license plate numbers of the vehicles, and it will keep the log of all the information about the vehicles which have violated the traffic signal with their license plate numbers, date and time, and the location of those violations. If we talk about literature review, we have reviewed some research paper on the traffic signal violations and its impacts and the number of casualties in Pakistan due to traffic signal violations. And after that, if we talk about technical details, we have reviewed some research paper on motion detection, vehicle detection, automatic number plate recognition, simple mail transfer protocol for sending email through Python programming language, computer vision, and Internet of Things. By researching those research papers, we have used the most easily available tools and which needs less processing power, so we can implement on our local PCs. So you will see in the later slides what technologies we have used to implement our project. So in this methodology chapter, we are going to talk about hardware development. So it is basically based on two milestones. First was the development of miniature traffic and road environment model. For this, we have designed our model on Adobe Photoshop and then printed that. And it was comprised of our traffic signal controllers, traffic lights, and a camera module to detect the vehicles moving through that road. And then we developed the traffic signal controller. First, we tried to develop this controller by using the 555 timer, but there were some complications about precision. of time. So then we were shifted towards the Arduino microcontroller for switching of the lights between green to yellow and yellow to red at the specific time instant. So this is the block diagram of our project. First, our system will check if the signal is red, then it will move towards the capturing video. If the signal is not red, then it will not capture the video. So when it will capture the video, it will detect if the vehicle is moving, and if the vehicle has crossed the virtual line, that is over the zebra crossing on the miniature model, then it will instantly save that frame onto the local PC and feedback the information to the authorities. And then it will be this process will continually running in the loop. And the frames that are saved on the local PC then will be sent to the automatic number plate recognition module for the recognition of license plate numbers. So now we are going to talk about software development. The first milestone was the synchronization of our traffic detection module with the traffic signal lights. For this purpose, we have used the datetime library of Python and sleep function to synchronize our Python code with the traffic signal controller. And after that, our next milestone was to detect the moving objects during the red signal. For that purpose, we have drawn a virtual line on the frame pixel by using NumPy arrays. So the purpose was that if the any moving object cross that line, then it will detect as an anomaly. For detecting the moving object, we have used the background subtraction techniques of image processing, and we have used OpenCV methods for background subtraction. And then we have used binarization. The purpose of binarization is to convert normal image into grayscale image. Binarization is necessary for the next step, that is morphological transformation. And in the morphological transformation, the object is getting more clearer, because in the morphological transformation, two techniques like dilation and erosion are used, which can make the object more clearer. And after that, we are using finding contours to specify that object on the frame. And then the anomalous frames are being saved on the local PC, and the instant email is sent to the authorities. Now, the second part was the license plate recognition. So to recognize the license plate numbers, so these were some steps. First of all, the frame or the image is converted into grayscale. And after converting it to grayscale, then we are using bilateral filtering. This will actually remove the noise from the image so it can be easily recognized. We are using OpenCV methods for this bilateral filtering. And after that, we are using canny edge detectors to draw the edges on the image so it can specify the license plate area on the image. And then we are using finding contours and masking the image to locating the license plate on the image, and then cropping that specific area which is concerned to only the license plate, and then we are sending it to the easy OCR methods for the text detection. And then that text is saved on the files. So these are the results of our project. Here you can see that the vehicle is moving through the road, and later you will see on the console video that this is being detected by our software, and the frames are being saved on the PC. So here you can see that the vehicle has just crossed the zebra crossing line, and our system has detected it as an anomaly. And now the system is saving those images onto the local PCs. So here you can see that it is one of the image that is detected by our system as an anomaly, which is saved on our local PC. So this original image is being converted into grayscale image, and then we are using canny edge detector for the edge detection of the image. So it can get more clearer the license plate area and the number on that license plate. So here you can see that the image is being masked, and the area that is specified by the license plate is located, and then it is being cropped, and the cropped image is being sent to the easy OCR, and after that you can see that the license plate number is being recognized and printed on the original frame. So after detecting those, recognizing those license plate numbers, so our software is seeing all that information on a Word file. You can see that the license plate numbers with the other information that is related to time and the date of those images is being saved on the file. And that file is also being sent to the authorities for confirmation and details about the total violations during the day. So, by completing this project, we have learned new technologies related to image processing and computer vision. We have designed an alternative solution to the manual system, which is cheap and more reliable, because a human can make mistakes, but this system is can't make mistakes. Yes, there is some chances of mistakes, but human errors can be removed by using implementing this method. This method will ensure the road safety and reduction of the accidents in our city, and it will implement an advanced and modern transportation system in a city. And this system can also be used as a research for the research paper for getting an idea about the total violations happening in a specific region. And we have completed all the milestones which were discussed in the aims and objectives, and completed this project successfully. If we talk about future recommendations, in the future, there can be provided a graphical user interface for this project, and both of the modules, like vehicle detection module and the license plate recognition module, can be integrated if the more graphical processing power is used. And this system can be integrated to any city where the infrastructure for CCTV cameras is available. Just we need to implement this model, and it can be used for vehicle detections. These are some of the references we have used to learn and review some currently used technologies for the vehicle detection, motion detection, and license plate recognition. Thank you very much. This is from our side.